When I tell people that they can run most AI systems directly in their browser, they don't believe me. Now, a year ago, I wouldn't have believed it either, but right now I have AI chatting with me in real time inside Chrome without a server. And that's just one of 5 AI models in this video's project. There's speech to text, image classification, object detection, real-time tracking, and more. All of it running on your machine through the browser directly with no server or complex, expensive API keys. If you watch this video, I promise you'll understand the secret of running local AI systems directly in your browser. Welcome to my BrowserAI website, and this is a full website that you can run yourself to try out many different AI models like image classification, LLMs, computer vision, all running locally in your browser. And I'm going to prove to you today that it runs locally by going through all these use cases. So let's start with image classification. The way that this works is that this 18 megabyte model will be downloaded in a cached session inside of your browser. This is necessary because we don't have some kind of server in the middle that's serving the AI model. So in this case, I've already got it cached and it loaded very quickly. And I'm able to just drop in an image. So in my case, I'm just going to drop in an image of a lion to see if it can classify it properly. We're going to double click on it, and there you go. It's very confident that this is a lion, which makes a lot of sense. And I can try one more example here with this cat. Specifically, it's an Egyptian cat. So very nice. This model is quite capable in doing image classification. But of course, the point is that it's running fairly quickly. It's able to recognize this cat at 230 milliseconds, and it's all happening locally. And to prove that it works locally, I think it's easier to show an LLM chat. This LLM chat is using a local Llama 3.2 model, so it will take a little bit of time to download. In my case, though, I've got it all cached, and I can just press one of these example prompts like writing a haiku about AI. And you can see here that many tokens per second get generated. This was so quick that, I couldn't even show you an increase in GPU utilization here. So instead, what I'm going to do is I'm going to copy quite a large part of this Wikipedia article. I'm going to paste it into this chat and then say, summarize this article, because now I will have to use the GPU for a bit of a longer time to process this much larger prompt. And you can see now that my GPU is basically being fully utilized, and it is now generating a much longer response. And the moment that the response is done generating, the GPU utilization drops. It's still being used a little bit because I'm recording this video right now, but clearly this is all running on my local GPU. There's a huge advantage to using WebGPU because it allows you to build a seamless web app without the need to build a complex installable desktop application, but you can still use someone's real local hardware to run AI models properly. You have to find a bit of a balance here though, because some of these models are really big, 700 megabytes. You don't want your end users to have to pull those models. So let's have a look at a much slimmer, but still impressive example, computer vision. By the way, you can find this entire web application for free in the link in the description below, so definitely check that out once we're done with this video. This model is just 5 megabytes, but it actually allows me to do real-time hand tracking. Let's see how it works. I'm going to go ahead and start this. It's going to load that model, and now I'm going to have to use one of my other cameras that I'm not recording with. Here we go. I'm going to go ahead and pull this up a little bit. So let's see. Here we are. That's looking good. And now we're going to allow while visiting this site. Here we go. This is me. So now what I can do is I can just do a couple of gestures, and it will be able to figure out what gestures I'm making. If I move the camera down like this, you can see that it still does a pretty good job of recognizing my hands. I can move this alongside and you can see that it sees that it's an open palm, and eventually it stops recognizing it once I hide behind my microphone. So this is a very small 5 megabyte model, but it's very competent. And the great part is that you can extend this model for your own use case and have it run simply on this web page. Even a pretty old device should be able to handle this AI model pretty well. So now we're going to have a look at this speech-to-text model that I have. And for this one, I'm using a slightly larger Moonshine-based model because this one is super good. I'm going to show you right now. I can simply load the model and start recording. And now you will see this waveform of my speech, and it will start transcribing the entire thing the moment that I press stop recording. So I think we've talked for long enough now. I'm going to press stop recording, and let's see how it does. So very quickly, it will say, and now you will see this waveform of my speech. Slight mistake here where you just want to have off my speech, but semantically, this is basically everything that I talked about. And it was able to transcribe 12 seconds of audio in just 567 milliseconds. So this is very quick as well. Lastly, I wanted to show you Semantic Search. And this is a very important model to run locally because it will allow you to make more complex AI models know your data. For example, you can use semantic search to search through your own documents to customize your own AI agents. Let me just show you what I mean by that. I'm going to load this model, which is a model that has stored a lot of embeddings, so representations of different concepts. So if I, for example, say preparing food, it will find a lot of information from that embedding model that relates to the concept of preparing food. For example, fresh herbs should be added at the end of cooking to preserve their aroma. And this is very quick. It was able to find all of this in just 6 milliseconds. Now, the great part about this is that by introducing semantic search like this, you can make sure that the smaller language models that run locally are grounded in the truth, that they have the latest up-to-date information of whatever solution you're building right now. And so all of these AI systems can work together to create a more complex system that all runs in someone's browser. Now, just a quick note before we move on, if you want to stay up to date with the latest and greatest in AI engineering, make sure to subscribe to this channel because I will keep you informed every single week with projects like these. So how does it actually work from a code perspective? Let's have a little bit of a look at that as well. If we check out our code base, you can see that we only have a front-end TypeScript project. There is no backend here. So then how are these AI models actually called? Well, we can have a look in the source folder, and then we can have a look at a couple of hooks that will check whether WebGPU is enabled, because not every browser has access to it. You need GPU acceleration for some of the AI models, like large language models, but other models might work just fine on the CPU. It just depends on what you're trying to do. Now we can also have a look at the components because in here we can find all the different demos. For this example, let's have a look at the LLM chat. You can see here that we have an LLM chat TSX file, which describes basically just the front-end components that get rendered in the web app. But it's more interesting to have a look at the worker because this one actually interacts with the Llama 3.2 engine to generate an answer. Now, what you see in here is something that, if you've ever done any kind of AI engineering before, actually is not that different from what you would create in a server. Here on line 35, you can see that we call engine chat completions create to create a response for all of the messages that are in the chat right now. And to do that, we're using the MLC engine API that is included in this web application as part of MLC AI, web-llm. So all of these nice web packages really are aligned with similar API structures that you might find when you're just creating an API request to OpenAI or a different cloud provider. But now you're doing all of that locally inside of the web application that calls a model that's stored in the browser storage, in the cache. And similarly, if we have a look at the image classification, all we need to do here is create a classifier object, which is using the HuggingFace Transformers library. And then the only thing we do here is call a weight classifier with the image URL to find the top 5 predictions. And that's it. The actual code to call the AI model is super simple because the community has done a lot of great work to abstract all of that difficult code away from you so you can just continue working on your use case instead of having to build hundreds of lines of Python code, for example, to interact with an AI model. Now, I do want to warn you that this is not for every use case. Sometimes it is not really appropriate to let your end users download AI models in their cache, especially if you're talking about an AI model that's 100 megabytes in size. But it can help you work towards an easy proof of concept that you can share with other people without you having to just create, a backend server and deploy that to the cloud. Now, the great part about this is that you can deploy this kind of web application pretty much for free because you don't need a complex backend yet to serve the AI model. If you're interested in building out this project for yourself, you're in luck because you can find it for free in the link in the description below. If you want more expert advice on deploying it, extending it, and becoming a high-paid AI engineer, check out my program AI Native Engineers as well.